All right, so I want to do another short video here, how to create a histogram. So we're going to look at this data set here. So look at the cat in the window. Doesn't like the videos. All right, so we have a data set here consisting of these data values. All right, so we got 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 data values. Our goal is to create this histogram that we can see down here. So our first task is to find what we call the class width. We are going to be asked to create a histogram with 6 classes, which means we're going to have 6 bars. Right, so we're told that we want 6 classes. So this is given information. To find the width of the classes with this many data points given this data and asked to find 6 classes, we take the difference between the highest value and the lowest value. In this case, highest value is 46, lowest value is 3. So we're looking at a difference of 43. We divide that by the number of desired classes. So we round up if necessary to find the class width. In this case, we divide 43 by 6. We get a little bit more than 7. So that tells us our class width is going to be 8. All right, so we start. So our classes are going to go from the lowest value 3, and we're going to add 8. We're going to add 8 each time. 3 plus 8 is 11, plus 8, plus 8, plus 8, plus 8. And the upper class limit is the lower class limit of the following class. Now, in order to avoid any confusion about, well, where the hell is 11 going to go? We subtract 1/2 from each of the upper and lower boundaries for each class to get the boundaries. Okay, so we subtract 1/2 from the class limits. We call this the class limits to get the class boundaries. So we subtract 1/2 from 3. We subtract 1/2 from 11 to get 10.5. The upper boundary of the first class is the lower boundary of the next. That's why, remember, we said histograms don't have any space between the bars. And that's how we create that effect, by subtracting 1/2 from each of the limits to make sure there's no space between upper boundary, lower boundary. And we can see again, we're adding 8 to each value here, and we're adding 8 to each value here to get our class boundaries. All right, so now we're counting up the frequencies, just like a frequency chart, and counting the frequency of values, the number of values in each class section. So we count up between 3 and 10, we have 5 values. Between 11 and 18, because these are all whole numbers, we have 5 values. Between 19 and 26, we have 6 values. Between 27 and 34, 2 values. Between 35 and 42, 1 and 1 value. Over 42.5 and less than 50. We can check that with the values up here if you want to double check. You can trust me on it. Okay, this leads to our histogram. So our histogram, the largest frequency is 6. So I made our graph here go up to 10 just to fit all the values. And the boundaries, the lowest boundary is 2.5, so that's where we're starting, down here at 2.5. And then we're having our class boundaries 2.5 plus 8, plus 8, plus 8, plus 8, and so on. Constructing the height of each bar according to the frequency of values within those boundaries, and we create our histogram. This gives us an idea of the shape of the distribution. In this case, we would say, if we were to draw a curve, something like this, we might say that is slightly skewed to the right. Right? Remember, we talked a little bit about skewness in class. This would be slightly skewed to the right. But there's we got 20 values, but it's not really a whole lot of values. But that's the idea. You take a set of data you construct the classes, the class boundaries, the frequencies, and that leads you to a histogram. All right, see you next time.